Yeah, children, video audience. So 8.2 children, midpoint theorems are children. All are midpoint theorems. Okay, so 8.2 exercise, 9 cbse quadrilaterals. Quadrilaterals. Okay, children. So first question, children, what is midpoint theorem? Before starting the exercise, let me teach what is midpoint theorem. Children, midpoint theorem states that in a triangle, if a line is drawn touching the midpoints of two sides in a triangle, if a line is drawn touching, this is midpoint, suppose this is also midpoint, then this line, if D and E are midpoints, if D and E are midpoint, then midpoint theorem states that DE is parallel to BC and DE is half of BC. Children, if D and E are midpoints, try to understand, children. If D and E are midpoints, if D and E are midpoints, then midpoint theorem states that DE is parallel to BC and DE is half of BC. This is midpoint theorem. Let's do some numeric sums on this exercise. First sum. Okay, the first sum is there. First sum is there. They have given a quadrilateral. They have given a quadrilateral. This is A, this is B, this is C, this is D, and they have given that. This is given like this. This is S, R, and P, Q. P, Q. What is given in this, children? He said that S, R, P, Q are midpoints of respective sets. Required to prove. What is required to prove? Means we have to prove that SR is parallel to AC and SR is half of AC. In the same way, we have to prove that PQ is equal to SR, and also we should prove that PQ SR is parallel. This all things we have. Let's start. Seriously see, there is a triangle DAC. In DAC, anyone wants to say this one? In DAC, S and R are midpoints. Become S and R are midpoints by midpoint theorem. By midpoint theorem, SR is parallel to AC and SR is half of AC. SR is parallel to AC and SR is half of AC. In the same way, in BAC, Vikram, tell me in BAC what happens? P and Q are midpoints. Tell me.
Sir, in BAC, P and Q are midpoints.
P and Q are midpoints by
midpoint theorem.
By midpoint theorem, PQ is
Q equal to
parallel to AC.
AC.
PQ is parallel to AC and PQ is
Q is half AC.
Half of AC. Now you see here, SR is parallel to AC. See here, SR is parallel to AC and PQ is also parallel to AC. When SR and PQ both are parallel to AC, we can say SR is parallel to PQ. Can I say? SR is parallel to AC and PQ also parallel to AC. So SR is parallel to PQ. And in the same way, SR is half of AC and PQ is also half of AC. SR is half of AC, PQ is half of AC. Means SR is equal to PQ. SR is equal to PQ. When opposite sides are equal and parallel, when opposite sides are equal and parallel, we can say that PQRS is a parallelogram. Because we understood some?
Yes, sir, I understood.
First, I have taken BSc, then I have taken BSc. That's it. I told these both are parallel, I told these both are parallel, so these both are parallel. I told this is half of this is half of this, so these both are equal. So since these both are equal and parallel, when opposite sides are equal and parallel, it is a parallelogram. Okay, children? So next. Everything is midpoint theorem, children. Not complex. Second one is saying that ABCD is a rhombus. Please see here, children. ABCD is a rhombus. A, B, C, D is a rhombus. Okay, and PQRS are the big points. P, Q, R, S are midpoints. P, Q, R, S are midpoints. See here, So PQRS are the midpoints of AB, BC. BC, PQRS are the midpoints. Okay. So children, given you see PQRS are midpoints they have given. Okay. Required to prove what we have to prove means we have to prove that PQRS is a rectangle. That's all. PQRS is rectangle. Rectangle. First, let us do parallelogram, then we'll do it as a rectangle. Okay. So join B. Join B. So join B. Construction. Okay. Who will tell ABD triangle? Anyone wants to say ABD triangle? Tell me ABD triangle.
In triangle ABD, P according to midpoint theorem, PS is P
and
and
S
S
are midpoints. By
midpoint theorem.
PS
PS is half of PS is parallel to BD.
and
PS is half of BD.
In the same way, can you tell for CB?
Yes, sir. In triangle CBD, Q and R are midpoints.
Q and R are midpoints. By
midpoint theorem.
By midpoint theorem.
QR is parallel to BD and QR is half of BD.
QR is half of BD. Okay. Now, since PS is parallel to BD, QR is parallel to BD, what we can say from this both?
PS is also parallel to QR.
PS is also parallel to QR. In the same way, PS is half of BD, QR is half of BD.
So PS is equal to QR.
When opposite sides are equal and parallel, what we can say?
It is a parallelogram. PQRS is a parallelogram.
PQRS is a parallelogram. But he is asking rectangle. So when it is a rectangle, means you have to prove this is 90 degrees.
Yes.
If it is 90 degrees, you want to prove, how you will do?
Sir, we need to
join AC.
Join AC.
Join AC. If you join AC,
since sir in rhombus diagonals bisect.
In AC and BD, diagonals bisect
each other.
Perpendicularly. Diagonals bisect
perpendicularly each other.
Perpendicularly means angle O is 90 degrees.
Angle O is 90 degrees.
If angle O is 90 degrees, and this angle 1 also 90 degrees. Can you say why?
Degrees.
Why?
Yes, the co-interior angles.
Co-interior angles are
supplementary.
And in the same way, angle 2 also 90 degrees. Can you say why?
Co-interior angles are supplementary.
Fantastic. Co-interior angles are supplementary. Now this is 90, this is 90, this is 90 means angle P also
90, sir.
By
a angle sum property.
Angle sum property. If P is 90 degrees, so what is angle S, angle R, angle Q also
90 degrees.
So parallelogram is a?
So P parallelogram having one side 90 degrees.
Is a
one angle 90 degrees is a rectangle.
Very good. Very nice. So like this you have to mention. So if this is 90, this is 90, this is 90. If 3 are 90, automatically P will become 90 by angle sum property. If P, S, Q, R are 90, is a parallelogram is a rectangle. That's it. Okay, next, third assumption. See here, third assumption. Third assumption. So third assumption is there like that. ABCD is a rectangle. They have said that ABCD is a rectangle. They only do ABCD is a rectangle with PQRS are the midpoints of P, Q, R, S are midpoints. Children, see here, P, Q, R, S are midpoints. P, Q, R, S are midpoints, they said, and we have to show that it is a rhombus. Required to prove is P, Q, R, S is rhombus. Exactly converts to the previous sum, children. Previous sum, they said rhombus, we have to prove rectangle. This sum, if they said rhombus, we have to prove it as a rectangle. So they said rectangle, we have to prove it as a rhombus. Okay, so anyone wants to say, children? Anyone?
Sir, can I say?
Yeah, tell. EPS, 1 second. Construction. Construction.
So we have to draw construct D to B a line.
D or AC, anything is okay. DD or AC, but I am drawing D. Yeah, in ADB you tell.
So ADB triangle.
X and P are
and B are midpoints.
by
Midpoint theorem.
midpoint theorem. SP is
SP is parallel to DB.
BD and SP is half
SP
of BD.
half of BD.
In the same way, tell me CDB.
So CDB triangle, where R and Q are midpoints by midpoint theorem.
By midpoint theorem,
RQ is parallel to DB.
RQ is parallel to BD and
RQ half BD.
half of BD. Okay. So now, so SP is parallel to BD and RQ is parallel to BD.
BD.
So SP is parallel to RQ.
To RQ.
SP is half of BD and RQ is half of BD. So SP is equal to RQ.
RQ.
If opposite sides are equal and parallel, we can say PQRS is a
Rhombus.
no parallel. Opposite sides are equal and parallel means it is a parallelogram. Now we have to prove it as a rhombus. How to prove it as a rhombus? Means all sides are equal. If you prove it is enough. All sides are equal. If you prove it is enough to prove it as a rhombus. How do you prove it is a rhombus? So children, Vikram, just see here. Now remove this. Just join SQ. Join SQ. Now can you see two triangles are there here? Can you see two triangles? What are the triangles names? PAS and PBQ. PAS and
PBQ.
tell me. AP is equal to BP.
AP equal to PB.
And why? Because P is a
P is a
midpoint.
midpoint.
Angle A is equal to angle B. Why?
So 90 degrees.
90 degrees because it is a rectangle.
Rectangle.
AS is equal to BQ. Why?
Sir, AS equal to P.
Because AD is equal to BC in rectangle and half of AD, half of BC because S and Q are midpoints. By SAS, we can say PAB is congruent to PBQ. By CPCT, what we can say? By CPCT, we can say PS is equal to PQ. PS is equal to PQ. Already opposite sides are equal. We proved here. Now adjacent sides also equal. If opposite sides and adjacent sides are equal, it means all sides are equal. If all sides are equal, it is a rhombus. It is a rhombus. Next question. Fourth question. ABCD is a trapezium. ABCD is a trapezium. ABCD is a trapezium. Each children of BD is joined already. BD is joined. Okay. And EF is joined like this. They have given in the book. EF is joined like this. So please check children given is the given structures what they have said means. So what they said, ABCD is a trapezium. They said BC is parallel to AB children because it is a trapezium. And they also said that E and F are midpoints. E and F are midpoints. They said children. E and F are midpoints. Okay. No. Show that no. F is midpoint. E is midpoint children. Sorry. E is midpoint. We have to show that F is midpoint. Okay. Diagonal E is a midpoint. A line is wrong. And he said that EF is parallel. EF is parallel to CD and parallel to AB. Children, already these both are parallel because it is trapezium. Now this is also parallel means all three are parallel. Now we have to show that F is midpoint. Just we have to show that F is midpoint. Anyone wants to say?
Sir, can I?
Yeah, no,
In triangle ABD,
very good. In DAP.
E is midpoint given.
Is midpoint. Okay. Very good.
EF is parallel.
EK is EF or EK? EF or EK. Very good. EK is parallel to EK.
EK is parallel to AB
By
midpoint theorem.
Converse
Converse
of
of midpoint theorem.
K is midpoint.
And A is midpoint.
K is midpoint. Very good. Now in the same way, tell me BDC. Very good.
Sir, BDC. Okay.
In BDC,
G is
K
K
is
is midpoint. K is midpoint. KF is parallel to DC.
K is parallel to DC. So
By converse of midpoint theorem,
midpoint theorem,
F is also a
midpoint. That's it. F is also midpoint. That's all you ask. Very good. Ma'am. So children, if E is midpoint and these both are parallel, K is also midpoint by converse. If K is midpoint and these both are parallel, F is also midpoint by converse of midpoint. Like that we have to. Very good. Okay, children, good. Some. So children, A, B, C, D, F, E, B. Okay, children, B is there. So children, what is given means ABCD is a parallelogram. Children, ABCD is first they have given parallelogram. Children, it is given. I'm telling about given. ABCD is the parallelogram they have given, and E and F are the midpoints. E and F are midpoints they have given. E and F are midpoints they have given. Children, E and F are midpoints of size ABCD. Show that AF and EC bisected. Children, we have to show that BD is bisected. BD is bisected. This are equal. This three are equal. We should show. BD is bisected means is divided into three equal points. That's it. That's it. Okay. So ABCD is a parallel. Children, E and F are midpoints. E and F are midpoints. Okay, children, we have shown that these three are equal. And they said that E and F are midpoints. E and F are midpoints. Okay. So anyone wants to say this something? They said ABCD is a parallelogram. E and F are midpoints. Show the line segment AF and EC is trisected by diagonal B. Diagonal B is trisecting. We have to say that's all. Yes, anyone wants to say children? Okay, sure. So AB is equal to CD children because it is a parallelogram. AB is equal to CD children because it is a parallelogram. Okay, so here I will see something. M I will say children, here some N I will say children. Okay, so ABCD is a parallelogram children. So AB is equal to CD. This whole thing is equal to this whole thing. Now AB by 2 is equal to CD by 2 because E and F are midpoints. E and F are midpoints. This is midpoint and this is also midpoint. Therefore, CF also equal to E. CF also equal to E. In the same way, again I am saying this and children. AB is parallel to CD because it is a parallelogram they have given. Okay, children. If AB is parallel to CD, children, AE also will be parallel to CD. A is also. Now, children, A is parallel to CF and AE is equal to CF. If opposite sides are equal and parallel, AECF is a parallel. AE. Now, everything converts, children. Anyone wants to try? First, you have to try in this triangle, children. Next, you have to try in this triangle. That's it, children. You will get the answer. By converse, everything is converse. Anyone wants to try in VAN, children? VAN. Children, in VAN, anyone wants to say? Shemuk, tell them VAN. Yes, anyone wants to say BAN? E is midpoint. E is midpoint. EM is parallel to AM. Children, EM is because this is a parallelogram. Because this is a parallelogram, EM is parallel to AM. So by converse of midpoint theorem, M also midpoint. M also midpoint of VN. If M is midpoint of VN, children, VM is equal to M. And anyone wants to try it for DMC, children? Anyone wants to try for DMC? Tell me. Tell me. In DMC, F is midpoint.
F is midpoint.
F is midpoint. And FN is parallel
to MC.
FN is parallel to CM because it is a parallel. This is a parallel. Okay. So by
converse of midpoint theorem.
By converse of midpoint theorem. N is
also
midpoint.
midpoint.
N is midpoint means dn is equal to m.
dn is equal to nm.
dn is equal to m. And so dn is equal to m and dn is equal to m. So dm is equal to mn is equal to dn. That means VD is trisected. VD is trisected is divided into 3 equal parts. Simple children. Once you have to take this triangle, once you have to take this triangle, that's it. This is midpoint, so this is also midpoint. This is midpoint, this is also midpoint. By converse of midpoint. That's all. You need not worry about that. Very easy subject. Sixth question. Sixth question, children. Show that the line segments joining the midpoints of the opposite sides of quadrilateral bisect each other. Children, they have given a quadrilateral ABC, some quadrilateral. He's saying, show that the line segments joining the midpoints are P, Q, R, S. This line segments bisect each other. Children, given what means it? ABC is some quadrilateral. ABCD is some quadrilateral. And they said that P, Q, R, S are midpoint. They said. What required to prove means we have to prove that PR bisects SQ. PR bisects SQ. PR bisects SQ. Okay. So children, what I will do join. Children, I will do join. Okay, and join is join. The children join is. Can anyone wants to say about DAC children? DAC.
Can I, sir?
Yeah, tell.
In DAC, S and R are midpoints.
In S and R are
Midpoints.
Yeah.
SR is parallel
midpoint
by
theorem.
midpoint theorem. SR is parallel to AC. SR is half of AC.
In the same way, now try DAC.
P and Q are midpoints.
P and Q are midpoints. Okay.
By midpoint theorem.
By midpoint theorem.
PQ is parallel to AC.
Okay.
PQ is half of AC.
Half of AC. Now these both are. This is parallel to AC. This is parallel to AC. This is what we can say. SR is parallel to PQ. And SR
is equal to PQ.
If opposite sides are equal and parallel, what we can see?
It is a parallelogram.
Why? Because opposite sides are
parallel and equal.
Equal and parallel. So in parallelogram, what we know? In parallelogram,
diagonals bisect each other.
Diagonals bisect.
Very good. In parallelogram, diagonals bisect each other. Who are the diagonals? Who are the diagonals?
PQ and PR and SQ.
PR and SQ bisect. Hence, that's all, children. So we have to prove that PR and SQ bisect. We proved it because if this is the parallelogram, children, if this is the parallelogram, compulsory they both will bisect each other because the parallelogram diagonals bisect. We proved PQRS is a parallelogram. So PR and SQ compulsory they will bisect because it is a parallelogram. That's what he's asking you. So we proved it like this. Next. Seventh. So last sum for the day, children. So coming to the last sum, seventh sum. Children, seventh sum is the last sum for today. Very, very important, children. ABC is a triangle. Very, very important. This is the last sum, children. ABC is a triangle. Okay. In which right angle, let's see. I'm sorry, right angle. C is here. And this is B. ABC is a right angle triangle. A line drawn through the midpoint of hypotenuse. Okay. A line drawn through the midpoint M of hypotenuse. He's taking M is the midpoint of hypotenuse and parallel to BC. This is both are parallel. Children, given what is given angle C is 90 degrees. They gave M is midpoint. They gave and what is they given? MD. MD is parallel to BC.
Parallel to BC.
What is required to prove? We have to prove that D is also midpoint. First sum. Second one, MD is perpendicular to AC. We should prove. And third one, CM is equal to MA is equal to half of it. All the three. Who will tell this sum?
Can I, sir?
Sir, can I?
Yeah.
Second line.
Yeah. Some. Yeah. Nandika, you tell.
Yes, sir. But in triangle AACB, D is midpoint. Oh, we have to prove. Sorry, sir. Sorry.
M
We need
is
to prove M is midpoint.
M is midpoint
And MD is MD is parallel to BC, and
by
MD is by converse of midpoint.
theorem, by converse of midpoint theorem.
Midpoint theorem. D is also midpoint.
D is also midpoint. First one is over. Second one, Shenmukh will take. Shenmukh, prove
Yes,
that
sir.
MD is perpendicular to AC.
Sir, first we should join MC, sir.
No need, Nana. No need.
Okay.
MD is
So,
parallel to BC, no, man.
So angle D is equals to angle C. Co-inter angles are supplementary.
Angle C and angle D are 90 degrees. Sorry, 180. Why? Why?
180.
Co-inter
Co-inter
angles
angles are supplementary.
but this is 90, we know. This is D. This is 180.
90.
So angle D also 90.
90 degrees.
Okay. Now, Yashas,
Tell.
Hansika,
Yes, sir.
tell the third one.
Join CM
Join CM. Yes, Nana.
in triangle MAD.
MDC and MDA. Very good.
MAD.
Very good.
MD is equals to MD.
Okay, you understand there. Okay, Nana. MD is equal to MD because
Common.
side. Very nice. Angle D is
Angle
equal to
D is
angle D.
equals to angle D, 90 degrees proved.
Okay.
AD is equals to CD.
Why?
D is midpoint.
D is midpoint. Why?
SAS congruency.
SS congruency. MDC
MDC
is congruent to
MDA.
MDA. By CPCT, what we can say now?
AM is equals to CM.
By CPCT, AM is equal to C. AM is equal to CM.
CM.
AM is equal to CM. Now, how to prove that CM AM is half of AB? Can you do or shall I tell now?
I will say, sir.
Tell.
AB is equals to AM plus BM.
AB is equal to AM plus BM.
Plus
Fantastic.
BM.
Fantastic.
AB is equals to 2AM.
AB, why? Because AM and BM are equal. Because M is the midpoint. So 2AM. Okay. Very good.
AM is equals to
AM is equal
AB
to
by 2.
half of AB. But AM and CM are equal. So AM and CM is equal to half of AB. That's how we have proved all the sums of midpoint theorem and 8-point exercise. Very good. Those all answered me. Vikram, you asked me, but you did not even answer single one.
Sir, answered, sir.